So I want to review about moles and molar mass. Okay, so first we want to just kind of talk about moles. Now when we're talking about moles, remember moles is really just a counting unit. And when we're talking about counting units, we're talking about specific words that really means a very specific number. So example of a counting word, we have dozen. We know in the English language, dozen means 12. Or when we talk about a pair, like, hey, I'm buying a pair of sneakers, or where the case is, we know that means two. There's other prefixes that we have used, that we use in the English language, like every time we talk about octa, we know we're talking about 8, or hexa, we're talking about 6, okay? So these terms specifically mean a specific number. And so mole, it's the same thing. All right, so when we say, hey, we have a mole of something, a mole of a substance, mole of a particle, whatever the case is, we're specifically talking about 6.22 times 10 to the 23rd of that particular substance, whatever it may be. All right, so 1 mole of anything is 6.022 times 10 to the 23rd. And I know that number seems really, really large, but when you think about how small atoms are, it actually makes it easy for us to quantify atoms or particles or molecules, whatever it may be, and so that way we could do whatever we need to do with it. So in chemistry, this kind of works out really well. So for example, if we say, I have 1 mole of carbon, well, all that simply means that we have 6.022 times 10 to the 23rd atoms of carbon. If I say I have 1 mole of water, H2O, then we have 6.022 times 10 to the 23rd molecules of H2O, okay? If we say we have 1 mole of table salt, then all that simply means, again, you have 6.022 times 10 to the 23rd, this case would be formula units of table salt, okay? Bottom line, really, if you have a mole of something, you have 6.022 times 10 to the 23rd of that same substance. Which leads us to the next point, molar mass. Now, when we're talking about molar mass, it's basically the mass in grams of 1 mole of a substance. So let's take a look at this periodic table here. So now, on this periodic table, right, we have all our element symbols. And now the cool thing about periodic tables, it actually gives us and tells us the molar mass of each of the elements that we know. So for example, let's look at hydrogen here. So hydrogen, here we know that this is the atomic number. So the atomic number just basically represents the number of protons of that particular element. But then here we have the average atomic mass. So now the average atomic mass, once again, is just a weighted average of all the isotopes that and its abundance in nature, but also the average atomic mass. Through experiment, we know that it also symbolizes the molar mass of that particular element. So in this case, for hydrogen, the molar mass of hydrogen is 1.01. Now, this is true for all the elements that we have here. So, for example, we have lithium. The molar mass of lithium is 6.94. We have the molar mass of scandium here is 44.96. I mean, it doesn't matter what element that we talk about, the average atomic mass is also the molar mass. So phosphorus, 30.97, oxygen, 16.00. So it's all right there for you on the periodic table. And then you could use the molar mass to either help you figure out, hey, if you have a given amount mass sample of a substance, you could use the molar mass to figure out how many moles you have, or vice versa. And you could even use it, get to the point where you could figure out how many individual particles you have using 6.02 times 10 to the 23rd. Now, it's not just figuring out the molar mass of elements, but we could also use the molar masses to figure out the molar mass of compounds. Now, the cool thing about this is that the molar mass of the compound is just the sum of all the molar masses of all the elements that make up that compound. So, for example, here we have H2O. Right now, we see that H2O is made up of 2 H's and 1 O. Okay, so you could look at the periodic table and figure out, okay, well, if I know that, you could just take the sum of them to figure out the molar mass of the total compound. So we'll look at the periodic table and we see, okay, well, we have that hydrogen has a molar mass of 1.01, all right? And so 1.01, and we need to take account that there's 2 of them, so we'll multiply this number by 2, all right? And then oxygen has the molar mass of 16. So if that's the case, you have 16.00. All right, and so that all you really have to do, you just got to add these up. So here it's 2.02, this is 16. So that means in total, the molar mass of H2O is 18.02. All right, and the units for molar mass is grams per mole. Okay, so that's just pretty simple enough. I mean, we could do that for simple compounds like water or methane, which is CH4, or very complicated particles where such as you know, DNA, where it's just thousands and thousands and thousands of elements joined together. But all of this is just the sum of all the molar masses. So using the molar mass, we could easily convert between sample grams of a particular substance to knowing how many moles that we have, okay? So all we just have to do, we just got to know the molar mass, and we could easily go back and forth between those 2 units. So, example, let's just say you have a 6.54 grams magnesium sample, okay? And you want to know how many moles of magnesium that you have, okay? So the first thing you want to do is you need to figure out the molar mass of magnesium. So you take your periodic table, okay? So here's my periodic table, and I'm looking, and I say, okay, well, the magnesium's right here, okay? And its molar mass is 24.31, okay? So what we'll do, we'll just do simple dimensional analysis to help us figure out how many moles of magnesium that we have. So we start off with 6.54 grams of magnesium, okay? So the conversion that we have is that we know that for every 1 mole of magnesium has a mass of 24.31 grams, okay? So now when we're doing the molar dimensional analysis, you always want to make sure that you want to keep that these units, whatever unit you start with, you want to cancel out. So if your unit you start with is a numerator, we got to put that same unit on the denominator so that it can cancel itself out. And whatever unit that you're going to, in this case here, we're trying to go to moles of magnesium. You want to make sure that the moles of magnesium is on the top, so that way at the end of the day, that's your answer, okay? And then we just plug in the numbers according to the conversion. So we know that for every 1 mole of magnesium, the molar mass is 24.31. Okay, and by doing this, we could easily cross out magnesium because they're the opposite sides of our fraction. Okay, so if you consider this to be a fraction, this is just simply over 1. So this is opposite sides of fraction, and all you simply have to do is just, you will multiply, in this case, 6.54 times 1 divided by 24.31. And then when you do that, you will find that the molar mass, or not the molar mass, but the moles in this case, of magnesium in the 6.54 gram sample is 0.269. And we always want to write our units. Okay, so there are 2.69 moles of magnesium, and if you take that many moles of magnesium, it's going to have the mass of 6.54 grams. So here's another example. All right, let's say that we have a sample of sulfur. It's 0.324 moles, and we want to know, okay, how many grams do we have, all right, altogether? And once again, like I stated before, all you really need is you need to know the molar mass of this substance. In this case, we need to know what's the molar mass of sulfur. So we'll look at the periodic table here, and we see the molar mass of sulfur is 32.06. So that's kind of be our conversion point to go between moles and grams. So in this case, all right, so once again, we're just going to use dimensional analysis. So we have 0.324 moles of sulfur, okay? And it's typically over 1. All right, here's our dimensional analysis. All right, so we're just going to be converting moles of sulfur to grams of sulfur. All right, so typically what you want at the end, you would like to have that unit at the top, or you don't want it to be canceled out, more say. So in this case, we want grams of sulfur. And what unit that we're trying to get rid of, we're trying to get rid of moles of sulfur. So because it's a numerator here, we'll put this in the denominator here so that it will cancel out. And so all you have to do then is just add those numbers accordingly. So we know that for every 1 mole of sulfur, the molar mass, or the grams, we have 32.0 grams of sulfur. And so now here in this case, all you have to do is just multiply and divide. So we will multiply 0.324 times 32.06 divided by 1, and what you will get is number that is close to, all right, so you'll get a number about, it's going to be about 10.3 grams of sulfur. So here's another example, all right? We have 6.34 grams of NaCl, table salt, and we want to figure out how many moles of NaCl do we have. So now here what makes this just a little bit different from the examples that we had earlier is that NaCl is a compound, okay? And just like we talked about before, to find the molar mass of a compound, you just got to look at the molar masses of the individual elements that make up the compound, and you add them up together. So like for example here, when we're talking about NaCl, we look in the periodic table and we see that Na, okay, has the molar mass of 22.99. Chlorine, Cl, has the molar mass of 35.45. And so if you want to know, okay, what is the molar mass, these are grams per mole, so just write the units. So if you want to know what's the molar mass of NaCl, it has the grand total of 58.44 grams per mole. All right, and so this is the number that we're going to use to help us to convert between grams of NaCl to moles of NaCl. So now that we have the molar mass, all we have to do now is just this, we just have to do the math. All right, now, so once again, we start off with 6.34 grams of NaCl. All right, so using dimensional analysis, we're going to moles of NaCl. All right, so I'm going to put this on top because that's what I want. All right, and I want to put grams of NaCl on the bottom because that's what I don't want. So since because I have grams here, I want to get rid of it. And by putting grams in the denominator here in the opposite side of this fraction, it'll allow me to get rid of it. All right, and so we know that for every 1 mole of NaCl, the molar mass is 58.44 grams. Okay, so now that we have that, we could simply just do the math. We could put this in the calculator. And so we see here that 6.34 grams times 1 divided by 58.44. And so by doing that, you put in the calculator, we have that your answer will be 0.108 moles of NaCl. Now recall that for 1 mole of a substance is equal to 6.022 times 10 to the 23rd of that substance. And this number is often called Avogadros number. All right. So here, 1 mole of substance is equal to Avogadros number, and which also, when we think about the mass, all right, if we have this much, then we have basically the molar mass, and that's the number that you find on the periodic table. All right. And so we could actually convert back and forth between grams, moles, and actually the number of particles, quote unquote, Avogadros number. Okay. So like, for example, let's just say we want to know, all right, in grams, if we have 3.214 times 10 to the 22nd atoms of H2, all right, and we want to know, okay, well, how many grams is that? Okay, how many grams of H2 do we have in this case? Okay, so just kind of work this out. Well, we have 3.214 times 10 to the 22nd atoms of H2. So we're going to use dimensional analysis to figure this out. So this is over 1. All right. So the first thing we're going to do, we're actually going to go ahead and convert this to mole. All right. And so what do we know? Well, we know that for every 1 mole of a substance, okay, we have, it's basically Avogadros number, 6.22 times 10 to the 23rd atoms of H2. Okay. The reason why we could do this because we're trying to get rid of this atoms H2 here, so we need atoms of H2 here. All right, and so we have that, and we could actually kind of continue this even further. Okay, because ultimately what we're trying to find is how many grams of H2 that we have. So that's what we're really kind of looking for here. So we could kind of bring this a bit further, take this one more step. All right, so we have moles here. Well, we need to kind of get rid of moles that's here. So getting rid of moles here, we put moles on the bottom, moles of H2. All right, and we're looking for grams. So I'll put grams of H2 up here, and that's just simply their molar mass. And so we know that for every 1 mole of H2, we look in the periodic table, and that we have, since 1H is 1.01, since there's 2 of them in this case, then your molar mass is 2.02. All right, and so when you want to do the math all together here, what you're simply doing is you are multiplying 3.214 times 10 to the 22nd times 1 times 2.02 divided by 6.022 times 10 to the 23 and divided by 1. And so when you put this in the calculator successfully, you should have that the mass of this many atoms of H2 is 0.1076 grams of H2. So that's your final answer. And basically, this is how you kind of navigate through moles and molar mass.